Hello everyone, welcome back to my YouTube channel. Myself Sneha Jagdish Budihar. I am studying in Sri Venkateshwara College of Engineering, Department of Electronics and Communication Engineering. Currently I am studying in the third semester and subject is Electronics Principles and Circuits. Subject code is BEC 303. Topic is explain the voltage control oscillator, that is the VCO. Let us discuss about the VCO. Introduction. Oscillator circuits whose frequency can be controlled or varied by a DC input voltage. This type of a circuit is also called a voltage to frequency converter. The output waveform from the VCO may be sine wave or other wave shape depending on the circuit design. Different types of VCO, that is the voltage control oscillator. First one, it is LC oscillators. LC oscillator means inductor and capacitor oscillators. Second one is crystal oscillators. Third one is clock generators, and last one it is frequency synthesizers. LC oscillators. LC oscillations are electrical oscillations that occur in a circuit made of an inductor and a capacitor. How it works? LC oscillators works only when a charged capacitor is connected to an inductor. The capacitor charge and the electric current in the circuit oscillate. The energy in the circuit flows continuously from the capacitor to the inductor, then causing the capacitor to charge and discharging in the cycle. You can see the diagram, that is the circuit is visible. Principle of LC oscillator. LC oscillations. The electric current and the charge on the capacitor in the circuit undergo electrical LC oscillations. When a charged capacitor is connected to an inductor, the electric energy stored in a capacitor. It is the initial charge which is named as a QM. It is also represented as QM. The inductor contains the zero energy. And second one, it is the crystal oscillator. A crystal oscillator is an electronic oscillator circuit that uses a piezoelectric crystals as a frequency selective element. The oscillator frequency is often used to keep track of the time as in the quartz or the waist watches. It means what? The stopwatches. To provide a stable clock signal for a digital integrated circuit and to stabilize the frequencies for the radio transmitters and the receivers. Principle of the crystal oscillator. A crystal oscillator is an electronic circuit that uses a piezoelectric crystals that generates the AC voltages when undergoes the mechanical vibration. It works on the principle of the inverse piezoelectric effect, which means when an AC voltage is applied to it, it vibrates and its natural frequency. You can see the diagram. Upper part of the diagram, that is the metal electrodes on the opposite sides, and the below that is the quartz wires, and the third one it is a wire holders, and the last one between two, that is the contacts. Clock generator. Design parameters for the VCO clock generator are turning voltage range, center frequency and the frequency turning range, and the timing jitter of the output signal. Jitter is a form of a phase noise that must be minimized in applications such as radio receivers, transmitters, and the measuring the equipment. You can see the diagram of the clock generator. There are the two capacitors C1 and C2, and the C1 is connected to the Cn and the C2 is connected to the IC. Here the resistors are, three resistors are present. One resistor is connected to the ground, that is R2, and the negative diode is connected to the R3, and the last one R1 is connected to the IC. Principle of clock generator. The principle of a clock generator is to create a periodic clock waveforms and that synchronizes the operations in a digital systems. The clock generator basic components are the resonant circuit and the amplifier. The resonant circuit is typically a quartz piezoelectric oscillator, but it can also be a tank circuit or an RC circuit. The amplifier circuit usually inverts the oscillator signal and the feeds some of the back to maintain the oscillations. Clock generator is an electronic oscillator that produces the clock signal to synchronize the operation of a circuit. The principle of the clock generator is to create periodic clock waveforms by generating or raising the falling transition on a signal parameter. The clock signals are then channeled to the designated place on the circuit board. And the last one, it is a frequency synthesizer. A frequency synthesizer is a circuit that can create multiple frequencies from a single frequency reference, and it is often used controlled oscillator. A frequency synthesizer allows the designer to generate the variety of the output frequencies as in the multiplies of the single reference frequency. The main application is generating the local oscillators, that is LO, signals for the up and down conversion of the RF signals. Principle of the frequency synthesizer. Synthesizers generates the audio through the various form of the analog and the digital synthesizers. In a subtractive synthesis, complex waveforms are generated by the oscillators and then shaped with the filters to remove the boost specific frequencies. Subtractive synthesis is characterized as a rich and the warm. Practical applications of the voltage control oscillator. First one, it is a wireless and the wireline communication system. VCO are used to local oscillators to provide a carrier to the mixer for up and down conversions. And second one, it is a phase locked loops, that is the PLLs. VCO are a part of the PLS and which are control system that generate a signal with a fixed relation to the phase of the reference signal. PLS are used in radio and telecommunications, computers and other electronic applications. And third one, it is the frequency modulations FM and the phase modulation PM. VCO can be used for the FM or the PM by the applying a modulating signal to the control input. Synthesizers. VCO can be used to generate the waveforms whose pitch can be adjusted by a voltage. And the reader applications. VCO are used in a linear FM or the chirped radar and in a FMCW. Embedded system. VCO are used in the microcontrollers and the digital signal processor. It can be used in the many of the industries also. Conclusion. Conclusion of the voltage control oscillator. Whether it is a decrease modular or the monolithic form, will need to the voltage based frequency control that is required in a number of applications, which is control system that generate a signal with a fixed relation to the phase of the reference signal. PLSs have a wide range variety of the uses in radio, telecommunications, computers and the other electronic applications. Thank you for watching the video. Please like the video.